So the final kind of topic we're going to talk about in this module is going to be adjusted R-squared. Adjusted R-squared. So a lot of times we're going to see that noted as R-squared with a bar on top of it. Or in Stata, it kind of just abbreviates adjusted. You'll kind of see it in that top right. In our regression results, you'll see this adjusted R-squared. So that kind of tells you what it is. So let's first talk about the motivation behind it, talk about how it's a little bit different than R-squared, and we'll talk about an application of when you want to use adjusted R-squared. And that's going to be to choose between non-nested models. So we'll talk about what non-nested models are and how we use it to choose between these non-nested models. So remember, maybe I'll put a dash there, remember, our normal R-squared, so not the adjusted, but the normal one, always increases, or at worst stays the same, but usually increases as we add more independent variables. So we got to make sure we don't think that this means that we should, our goal is not to maximize R-squared here, right? Our goal isn't just to add, everything in the kitchen sink into, in terms of variables into our model just to get the R-squared as high as possible, because we know it's going to go up when we add these more variables. So this does not mean adding a variable actually improves the model. So we can kind of artificially inflate any model by just kind of adding more and more and more variables, because any variable is going to somewhat explain some of the variation in our dependent variable, or most likely is. So the idea behind R-squared, adjusted R-squared, is another measure of goodness of fit. It's kind of an alternative, or maybe it's complementary, another measure of goodness of fit. And so what it does is it adjusted R-squared. When we add more variables, it doesn't necessarily increase in value. It can increase, it could decrease, or it could stay the same. Maybe I'll do a different color. Does not necessarily, just be an L there, increase as we add more variables. Kind of depends on the nature of the variables, how important they are in our regression, and explaining the variation y determines whether it goes up or down. So let's write out the formula here, and then we'll talk about it. I'll probably need to erase the board in a second though. So adjusted R-squared equals 1. Let me start again there. Got ahead of myself. It's 1 minus n minus 1 over n minus k minus 1. And the second term is multiplied by the SSR over the TSS of the SST. So this is this new term here, right? If we got rid of that term, then it just looks like our normal R-squared formula. N minus 1 over n minus k minus 1. So this is this new term. And so notice that this is less, this is going to be less than 1. Sorry, it's going to be greater than 1. Right? This is going to be greater than 1, which implies that adjusted R-squared is going to be less than R-squared. because we're subtracting a smaller number in adjusted r squared. Or sorry, we're subtracting a bigger number in adjusted r squared, so it's smaller than r squared. And let's think about what happens when we add another variable to our regression. There's going to be a couple different things that's going to be happening, right? When we add a variable to our regression now, this SSR is going to change, and K is going to increase by 1. And what happens to adjusted r squared is going to depend on which of these effects is bigger. But let's quickly erase this, and I'll write this again and kind of explain that really quickly again, and we can kind of write out these two effects that are happening. So let's rewrite that formula and kind of make sure we understand those points I was just making. So adjusted r squared is equal to 1 minus this new term times the SSR over the SST. So remember, that's different. This term is what's different. We're multiplying by this term, and that's what makes it different than the r squared. So let's just be more particular here. So notice, let's write out 3 things. A couple of them we've kind of already talked about. First is adjusted r squared is less than r squared. And again, that's because n minus 1, I know it took me a second to get there, but this is greater than 1. So we're subtracting a bigger number than we did before when we calculated r squared. The second thing is that adding a variable to the model has two effects. A, the SSR, well, hopefully will fall a bit. Right, so we add a variable, hopefully we're reducing the residuals, and so the sum of squared residuals will go down. So that's one thing that's going to happen, is we add another variable. But at the same time, this new term increases. So this is falls, I don't know why I have a capital there, but this falls, or decreases. Maybe decreases is better in terms of the language I'm using on the next line. Where the second thing that's happening is that this term is increasing. Again, let's get another color here, so hopefully it shows up. So the direction of change of this goodness of fit measure, which we're calling adjusted r squared, depends on which of these two effects is bigger. And the last kind of thing that I'll make note of is that adjusted r squared can be negative. All right, so the main thing that you should remember about adjusted r squared is it's basically giving you a penalty for adding new variables in. And that penalty comes through this new term that's being added, this B effect here. So we're still having a decrease in SSR as we add more variables, but now we're penalizing. We're penalizing you for adding another variable to the model. And so whether this adjusted squared, this goodness of fit measure, what we're calling adjusted squared, whether it goes up or down, is going to depend on which one of these two effects is bigger. So if we add a variable that explains a lot of the variation, why it's a really good variable to include in our model, the effect of A is going to be bigger than the effect of B, and our adjusted r squared would go up. Now, if we just add a variable that doesn't really have much explanatory power into our variable, the SSR isn't going to change very much. But this effect, this B influence of adding another variable is going to be bigger. It's still going to be there, and it's going to be bigger. And so then our adjusted r squared is actually going to go down from adding new variables. Okay, so let's talk about when we can use adjusted r squared to kind of choose between two different models.